Okay, we were on this lesson, changes in matter, lesson number 16, grade 10 part 2. So we discuss about these things and the chemical changes, what type of chemical changes were there, and yeah, these are the types of chemical changes: chemical combination reactions, chemical decomposition reactions, single displacement reactions, double displacement reaction. At the same time, we call it as double decomposition reactions. So we studied chemical combination reactions and chemical decomposition reactions, single displacement reactions, and also double displacement reactions. After that, we come to this part, chemical equations, and we go through this one. You see that in the left side, from this arrow, we call them as reactant, and the right side products. So here we have two reactants and one product. Then reactivity of metals. This is a 16.3 reactivity of the metals. Before that, let's go through this one. We didn't finish, I think. Chemical equations. A chemical equation is the symbolic representation of a chemical reaction using a chemical formula. When writing chemical equations in the standard form, reactants are written on the left hand side and the products on the right hand side. An arrow indicates the direction. So highlight this one. Arrow indicates the direction of the reaction. Arrow indicates the direction of the reaction. So left side it's reactants and right side it's products. Okay. Then in such instances, placing plus mark between them is the accepted way. Moreover, the reacting substances as well as the substances produced are indicated by their chemical symbols and formula. To write a chemical equation correctly, one should know chemical symbols and formulas as well. Now let us try to write the reaction between magnesium and oxygen in form of an equation. So here that they teach you how to write an equation. So here you could see a well-known equation, magnesium plus oxygen, it's magnesium oxide. So this is the direction of a direction of the reaction. Okay. So according to the law of conservation of mass, so highlight this one, law of conservation of mass. According to the law of conservation of mass, you have learned atoms are neither created nor destroyed during a reaction. So this is the law of conservation of mass. So the number of atoms of a respective elements in the reactants should be equal to the number of atoms in the product. So in this side, you have to count the number of atoms, and in the product side also the number of atoms. So it should be same, because according to the law of conservation. What is the law of conservation? Atoms are neither created nor destroyed during a reaction. The number of atoms of respective elements in the reactants should be equal, okay, should be equal to their number of atoms in the product side. Okay. Equating the number of atoms of reactants with those of the products is known as balancing the equation. So highlight this part. This is a balancing of the equation. Here count the number of atoms in the left side. In first instance, you have to write just the reactants and the product. So it is magnesium and oxygen. Oxygen means oxygen gas, so you have to write it as O2. Then in the right side, it is magnesium oxide, MgO. So now we are going to balance this one. Let's see how we are going to do it. There are 2 oxygen atoms in the reactants. Products contain 1 oxygen atom. To balance oxygen, magnesium oxide cannot be written as MgO2 because the formula of magnesium oxide produced by the above reaction is MgO. Remember how we write these molecules using the valency theory? So if I write it like this, it is magnesium and oxygen. What are the valencies of them? For magnesium it's 2. Why? Because it's in the second group of the periodic table, and when it comes to oxygen it is in the 6th group. So what is the valency of it? It is also 2. So how we write the molecule? We write the molecule like this by you have to write these 2 for magnesium and these 2 for oxygen. So the end formula comes like Mg2O2. But what we do for these 2? We could cut this one because they both contain 2. So the final formula is just MgO. Remember, I'll give you a paper with these valencies and practicing paper for writing these formulas. Okay. Follow the following steps to balance the above equation. There are 2 oxygen atoms in the reactants. Okay, we learned it. And products contain 1. Here 2 in reactants and product 1. Then to balance oxygen, magnesium oxide cannot be written as MgO2 because the formula of magnesium oxide produced by the above reaction is MgO. Therefore, 2 is written in front of MgO. See, we have to write this 2 in front of MgO. So, because there should be a method to make this oxygen into 2 atoms, but we can't put 2 here. So we have to put it in here, and after we put it in here, what happened to magnesium? Oxygen is balanced now because this oxygen gas has 2 atoms as O2, and here for this compound magnesium oxide compound, oxygen is in 2 is in here, so that means 2 oxygens. But what happened with magnesium? Then magnesium also becomes 2 atoms in the right side. So you have to balance, in order to balance this, you have to put 2 in front of this magnesium element. Okay. When writing 2MgO, 2 magnesium atoms are present in the products. 2 in products. But there is only 1 magnesium atom on the reactant side. So 2 should come in front of magnesium. This gives the following equation. Here 1 magnesium present in the reactant side, so you have to put 2 in front of this magnesium. So this is a balanced chemical equation of the reaction between magnesium and oxygen. Okay, so we've done with that one, and now they have given another example for you. So just discuss it. Study carefully how the balanced chemical equation is written for the following reaction also. Reaction is what? Aluminium. Select another color. Okay. Reaction is aluminium metal reacts with dilute hydrochloric acid, forming what? Aluminium chloride and hydrogen. So this is the unbalanced formula. This is aluminium and HCl, and this is the 2 compounds it form. One is aluminium chloride, the other one is hydrogen gas. And when it comes to here, 3 chlorine atoms, and see, 3 chlorine atoms are there and 2 hydrogen atoms are there. So when it comes to chlorine 3, you have to put 3 in here. But if you put 3, hydrogen becomes 3 in the reactant side. So in the product side is 2. So it will get complicated. So let's see how they have done it. 3 chlorine atoms and 2 hydrogen atoms are present in the products. 3 chlorine and 2 hydrogen in the products. Since the least common multiple of 2 and 3 is 6, write 6 as the coefficient of hydrochloric acid. So you have to write 6 in here. Okay, I have highlighted both. Need to erase this one and highlight only this 6. Okay, then see, now we have 6 chlorines in the reactant side, but in the product side it's 3, so you have to put 2 in here. Then let's multiply 2 into 3, it becomes 6. Okay, now it's correct. And what about hydrogen? It has 6 in here, but we have 3 in here, so we have to put 3 in the product side, and then by multiplying 3 from 2, it becomes 6. Okay, now hydrogen, the number of hydrogen is correct and number of the chlorine is correct. And see the number of atoms of aluminium in the right side, it's 2, and when it comes to left side, it just have 1. So you have to put 2 in here. Then you're done with the balanced equation. Okay, so this is the final outcome. Okay, Lamai, we've done with it. There are 2 aluminum atoms in the reactants, hence write 2 as the coefficient of aluminium. This is the balanced chemical equation of the relevant reaction. The method of balancing chemical equations as described above is known as inspection method. So there are different methods of doing this balancing of equation. Here we are calling this method as inspection method. Okay, I think you got it. And here you have some equations. They have given some equations, so you have to balance them. Balance the following equations by using the above method. What is the method? It's inspection method. So use this inspection method and try to balance the below 5 equations they have given. Okay, and after I come, I'll discuss them with you. Okay, that's assignment 2, no? Consider the word equation from 1 to 5 given below. Write balanced chemical equations for the word equations given. State to which type of reactions do those word equations below. Which type of reactions? Remember, there are 4 types of reactions: combination, decomposition, single displacement and double displacement. So you have to identify which type of reactions. This is after balancing the equation. Okay, first you have to balance the equation, then after that find out to which type of reaction this equation belongs to. Okay, I'll discuss the other part later. Here we have molecular weights and other things, so I'm going to discuss it later. Today I'm going to stop here and do this assignment and this given corrections. Okay, I'm going to stop here. Thank you.